Yesterday we got an introduction of what Pythagorean's theorem is and how we can use it to measure the different sides of a triangle. Well, now we're going to use that knowledge that we know and we're going to apply it here on a coordinate plane. So if somebody asked you what were the distance between these 2 points right here, well, if it was straight up and down, it would be really easy. We could count it. Or even if it was horizontal, we would just be able to count the units. But on these diagonals, there's not really a good way to do it. But now you guys know how to do it because you know how to use Pythagorean's theorem. All I want you to do is when you see diagonals on a graph like this or on a coordinate plane is I want you to draw a line straight down from one of them and then draw a straight line over to the other. And right there, we're going to form a right triangle. Can you guys see that right there? We have this right triangle. I'll erase some of these other lines for you. Oops, it's going to erase the whole line. Kind of how it works, huh? All right, we'll see if I can draw it better with the mouse. Probably not, because you all know that I'm amazing at drawing straight lines. All right, so now seeing that triangle, with what we know for Pythagorean's theorem, we should be able to solve for it. So let's see what we know. All right, what is the measurement of the vertical side here? It's a leg, and it is 1, 2, 3 units. All right, and what about our horizontal side? This leg, 1, 2, 3 units. Now we are able to fill in what we know using Pythagorean's theorem and solve for that diagonal, our hypotenuse. So we're going to have 3 squared plus 3 squared equals c squared. So we'll have 9 plus 9 equals c squared. We have 18 equals c squared. Get rid of that exponent by taking the square root of both sides. We can pull up our calculator here. And we'll say the square root of 18 is going to give us approximately 4.24. So C is approximately 4.24. Not too shabby, right? Okay, so let's try number 2 then. We're going to go ahead and draw our lines. Let's change our color in case I make too much, draw too much there. Oh man, that's a pretty good straight line for me. All right, here we go. So let's use our measurements of our legs that we have created. Remember, we're finding the measurement of our hypotenuse, so this is going to be our C right here. Well, this leg is 1, 2, 3, 4, 5, 6 is our vertical leg. Our horizontal leg is 2. So we're going to set it up in Pythagorean's theorem. A squared plus b squared equals c squared. We'll write that up here. And we're just going to fill in everything that we know. So 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 40 equals c squared. The square root of both sides to eliminate our exponent. Let's pull out our trusty calculator here. Oops, wrong mouse. So 40, the square root of it. We're going to have approximately 6.32. So we're going to know that 6.32 is approximately C. Not too bad. You guys are capable of drawing straight lines. I know you are. All right, now it wants us to find the perimeter of ABC. Well, this could be a little bit more difficult than up here. Let's see. Do we have any vertical lines that we can count units for? Doesn't look like it. What about horizontal lines? Yes, we do. We do have a horizontal line right here. AC, that line segment is horizontal. So let's see how many units it is. 1, 2, 3, 4, 5, 6. So we know that AC is 6. We will mark it as such. All right, now we need to find the measurement of AB. So what we're going to do is we're going to draw a line straight down from B straight down to that line segment. Now let's change our colors. So now AC is 6. We already know that. Now we're going to try to find AB. So we're going to change colors here. Okay, so this leg of this triangle that is created right here with AB and then this vertical line, this unit right here is 1, 2, 3, 4. 4 units. This line, the vertical, is 1, 2, 3, 4, 5. All right, so in order to find AB, we are going to say that 4 squared plus 5 squared equals C squared. All right, so we've got 16 plus 25 equals C squared. Then you're going to have, what is that, 41 equals C squared. Take the square root of both sides, and we're going to find out that AB, which is our C squared, square root of 41 is going to be approximately 6.40, so 6.4. Now, could I have drawn a triangle a different direction to do that? You bet I could have. I could have gone right here to right here. That's still going to give me 1, 2, 3, 4, 5. And that's also going to give me 1, 2, 3, 4 for my legs. I'm still going to use the same legs of 5 and 4 to find that. So we know we can prove it actually 2 ways, that AB is 6.4. Now the last side of our triangle that we need to find is BC. So we're going to take that same information again. BC will be orange, and it's going to be an approximation, I would have to assume. And we already have a right triangle drawn actually right here. So we know that one leg is going to be 2, and we know that the other leg is still going to be 5. So we're going to have 2 squared plus 5 squared equals C squared. We're going to go ahead and solve that. So we'll have 4 and 25. That'll be 29. The square root of 29 is what we are looking for here. That is approximately 4.385, which is 4.39 when we round. All right, now we have all of our sides. So now we can find the perimeter. All right, so we've got 6. I'm going to add them all up because the perimeter, remember, is just the outside shape. So 6 plus 6.4 plus 4.39 is going to be approximately 16.79. We add all of those together. So that right there is going to be our perimeter of the triangle ABC. So really that was a couple of different Pythagorean theorems all in one great big problem there, but I think that you guys are capable of doing that. As we move forward, they're also going to be giving you just points, and there's 2 different ways that we can do this. So there is something, a distance formula, and I know that we're all big fans of plug and chug formulas, so I just wanted to expose you to this now. You do not have to use the distance formula. You can graph the points that are given to you and go ahead and do Pythagorean's theorem just like we have done up here. There's nothing wrong with doing that. The distance formula is just something that some of us, we like to have that tips and tricks up our sleeve. So all it is distance equals the square root of the total x2 minus x1 squared plus y2 minus y1 squared. So each point here is going to be an x and a y, right? So this is x1, this is x2. Let's see if we can do that. So our x1 is going to be, it's just going to be the first point they give you. So this is going to be x1, y1. This is going to be x2, y2. All right, so all we have to do is just plug this information in right here that they give us into the correct spots and solve. So in number 1, our particular distance between those 2 points is going to be the square root of x2, which we saw right here is 3, minus x1, which is 1, that quantity squared, plus the quantity y2, which is -2, minus y1, which is -5. So we're going to minus a -5 there. That quantity squared. Okay, so we'll come over here. 3 minus 1 is 2. and 2 squared is 4, plus -2 minus a -5. That's going to give us a +3. Squared is going to be 9. Remember, we're still doing the square root. Okay, so now we're going to be doing the square root of 13. We can grab our calculator. The square root of 13, it's approximately 3.61. So we're going to say that the distance between those 2 points is approximately 3.61. Again, you don't have to use the distance formula. I just know that some of us prefer having a formula that's plug and chug. So you could use the distance formula up here if you wanted to. You could get the coordinate of this point and the coordinate of this point, pick which one you want to do for x1, y1, x2, y2, and plug it in. There's 2 different options for us to be able to find it on a coordinate plane or using coordinate points, the distance between them. So if you have any questions, as always, feel free to give me an email, message me on Remind, post in Google Classroom. I am here for you to explain some of it, help you through any of the questions that you have. Like I said, either method is fine. It's nice for us to be able to know how to do both of them. It's highly encouraged, of course. But if you have one that once you go through a few of them and you have a favorite method, go ahead and continue to do that. Your homework is posted in Google Classroom, and I will see you all later.